So I gotta add a little bit of something about permutations, which you guys should have just watched. Okay, and for the one example that I did, okay, yes, order did matter, but the nice thing about that problem was that after I took a coin out of my pocket, that was it. Okay, and what I mean is, in the example that I just did, I had a penny, a nickel, a dime, a quarter, and $half, right? So say during my first grab, I reached down and I took out a penny. Well, after that, there aren't any more pennies, all right? And then after I take out a nickel, there are no more nickels. Okay, but life isn't always like that. Sometimes you got a couple of pennies, sometimes you got a couple of quarters. Okay, so in that case, when you have those repeats, you need to account for those repeats. Because if I had, 2 pennies in there, well, if I reached that down and I pulled out a penny, did I pull out the first penny or the second penny? All right, because they're not the same. You have 2 different pennies that you can choose from. Okay, so when we have a permutation with something that has repeats in it, we need to account for those repeats. Okay, so we'll keep with this coin example. Okay, but let's assume I have 6 coins in my pocket. Okay, and this time, let's say I have a penny, I have a nickel, I have a dime, and then I have 3 quarters. Okay, now before, if I said I have 6 coins in my pocket and I wanted to pick all 6 of them, okay, if they were all different, so I'll do this in a different color, if all different, that would be just like the last example. We would say, oh, well, I have 6 coins, it's a permutation, I'm picking 6 of them, so I'm just going to get 6 factorial, which is 720 different ways. Okay, but in this case, they're not all different because we have these repeats, so I need to account for that. So instead, what I'm going to do is I'm still going to do this 6p6, which is 6 factorial, but since I have 3 things that are the same, I'm going to divide this by 3 factorial. Okay? Which is going to give me 6 times 5 times 4 times 3 times 2 all over 3 times 2 times 1. Oops, I forgot my times 1 over here. Not like it super matters, but cancel, cancel, cancel. So there are only 120 different ways to pull all of these coins out of my pocket. Okay, because I have 3 quarters, so I need to take into consideration those repeats. So, and I'll write it in general like I did before. Ooh, arrow, there we go. So in general, if we have n things, and we arrange all n of them with r repeats, that is going to be equal to n factorial over r factorial, which is what I did up here. Okay? I did my total number of things, which was 6, because I was taking out all 6 coins, and divided it by 3 factorial because I had 3 repeats. Okay, if I had, I'll go to a new page. Let's say I had a penny, a nickel, another nickel, a dime, a quarter, and a quarter. And I wanted to find out the number of different ways to take out all 6 coins. In this case, I'm going to do 6p6, or 6 factorial, but now we got to be careful because I have 2 repeats and another 2 repeats. So I've got to have 2 factorial for the nickels, and I have to have 2 factorial for the quarters. Okay, so it's for every group of repeats that you have. So this is really going to be over 2 factorial times 2 factorial, which is okay, and so this is going to cancel, cancel, and then if you want, you could leave this all over 2, or you could say, well, 2 goes in the 4 twice, so then you're left with 6 times 5 times 2 times 3, and in that case, you get 180. Okay, and that is, oh, no, not done, almost done. Whoop, whoop, whoop. Okay, because I'm just going to tack this on all the things that we've been doing so far have been permutations where order matters. But order doesn't always matter. Okay, go back to what I said at the beginning of the last video, which if I come in class and I say I'm going to pick 3 of you, and the first person I pick is going to be in first place, the second person I pick is in second, the third that I pick is in third, in that case order mattered. But what if I say, I need to pick 3 of you to go help Mrs. Wilson do something? Well, then it doesn't matter who I pick first or who I pick third, because you all have to do the same thing. And when order doesn't matter, we just call that a combination. So combination is an arrangement when order does not matter. Okay, and I'm going to do just one example, which is, let's say out of 23 students, I need to pick 4 volunteers. Okay, so this doesn't matter. It doesn't matter if you're my first volunteer or my last volunteer. Either way, you're my volunteer. Okay, and before we used P for permutation, here we're going to use C for combination. So we would write this as 23 choose 4. Okay, and it goes the same way. This is my total number, and then this is the number I'm using, or the number in my arrangement. Okay, and believe it or not, this also has a button in your calculator that we can use. Okay, and just like before, we need to go to 23, because that's my first thing. And then if I go into math, and I go over to probability, there, choice 3, that's my choose. And then what am I choosing? 4 people? Bam, 8,855. So out of a class of 23, if I need to choose 4 of you, there are 8,855 arrangements. Okay, because it doesn't matter if I pick you first, if I pick you second, third, or fourth. Those are all different types of arrangements. Okay, and in general, for n choose r, okay, this is the formula. We do this by doing NPR, so we do the permutation and then divide that by n factorial. So that is the formula for combinations. Okay, and the one thing that we do need to point out, okay, is that sometimes we use a different kind of notation for combinations. Okay, there is this n choose r, and I don't know why, but sometimes they also do these big parentheses with the n on top and the r on the bottom. Okay, this is not a fraction. There is no fraction bar in between here. Okay, but these both mean n choose r. Okay, and I don't know why my highlighter's not working right now. Let's try it. There we go. Okay, so we do need to know both types of notation because they can use both of these on the Regents exam. They're both fair game. And that's it. I am done.